Let's say you're bad at this. And that's okay. Because this is only good for one thing. Saving time. It does not get you a better answer. It just saves you time. Now, considering the fact that every single one of you will tell me every day I give you any amount of work that you don't have enough time to get it done, then maybe you should learn these things that get the work done faster. But if you choose not to, that's okay. But then you've got to make some time to do your practice, somehow. Now, if you are going to break that down all the way, it's cool to stick with 8 and 9, which I will do as soon as my computer allows me to write it. Eight and 9, and then that's going to be 2 and 4, and that's going to be 2 and 2, and that's going to be 3 and 3. And there is your group of 3. Looking like a tummy. Esophagus, small intestine, full of 2s. Which is funny, because eventually those 2s are going to become a number 2. Because they're going to go through the small intestine, then they're going to come out the bottom, and they're going to go through the large intestine, and then they're going to come out down there. See, you learn something new every day. No, you already all knew that. All right. What's different about 3? There's letters. But those letters represent what? Unknown numbers. And what does that little 3 tell you about that group of A's? That you have 3 of them. A. And what does that B tell you about the B's? You got 5 of them. B. And you are looking for groups of how many? 2. So it's real easy, isn't it? How many groups of 2 can I get out of there for A? 1. So there's an A coming out. And I left an A under there. How many B's? 2. 1, 2. So there's a B squared coming out, and I left a B under there. So right now I've got this. A, B. What else must I take care of under that radical sign? The 96. Now for me, I have done this enough. When I see 96, I see 16 times 6. Because the square 16 has a perfect square. What is it? 4. So what comes out? No. 4, the square root of 16, right? So out comes a 4. What's already out there? So what's out there now? 20. And what did I leave under there? 6. And now it's done. Even though I never once gave you an example with letters. Did I? Actually, I don't think I did. Maybe I did. I don't know. But math applies. It's the same thing. Over here, if I wrote 2 times 2 times 3 times 11, you would have taken out your group of 2. Because it was 2 squared times 3 times 11, right? Over here, it was A3, B5. 3 and 5 of them. Everybody cool? What if this was cubed? What would I pull out? 1A, 1B, but there'd be 2 B's left under there. Everybody with me? Cool. Now number 4. Number 4 has exponents all over the place. What is the instruction that is always given by math teachers at the top of a page of work like this? Now, that's what we tell you to do. But we're always trying to get you to simplify, right? Because there is no answer to these questions, is there? It doesn't equal anything. We just have to simplify it. So look for opportunities to make something in math look simpler. What can I do with that to make it look less ugly? I can simplify, but what? You can put the outside exponent in. Now, all of you remember that outside exponent goes to the 3 and the 2, but I'm betting a bunch of you forget that it also goes to the 3. And I can always tell because somebody always says, oh, when I draw that big arrow. Why does that little 3 go to that big 3 in this case? Because it's in the brackets. So this is really 3 cubed, which is what? What's 3 times 3 times 3? Nope. 27. X squared cubed. X to the what? 6. And y to the what? 9. Excellent. Now, what can I do down there? What's ugly down there? Too many x's. So let's get rid of them. What would I do with those x's? Add the exponents. But this one has no exponent, so it must be an exponent of 0, right? No. What's its exponent? 1. So I add 4 and 1. What is that? 5. So my denominator is 6x to the 5th. Now, what is really happening here? What's really happening here is I have 27 over 6, x over x, and y over nothing. So I got to deal with them all separately. What would you do if you were in Mrs. Bad Crumble's class and you saw that fraction? You're not allowed to make a mixed numeral because there's all this other stuff here. So what would you do with that, Christian? Simplify. How? Find the greatest common factor, which is what? 3. How many 3's fit into 27? 9. How many 3's fit into 6? 2. Excellent. 9 and 2. They are done. Now what do I do with 6 and 5 with my x's? I subtract. That's the shortcut. But really what I'm doing is canceling out 5 of them, right? These 5 are gone, and 5 of these are gone. So 1's left. Do I write x to the 1? No, I just write x. And what do I do with the y's? Leave it. Y to the 9th. Everybody Gouda? Great. You'll be writing a quiz on this in a little while. Okay? Okay. Everybody take a moment now. Talk to your friends. Shake your sillies out because I'm going to want your attention in about a minute on the next page of your notes, which I believe is page 103. I lie. It's page 104.
For this one, can you repeat how did you do this again? Please, sound that.
If there was no A and B, what would you do? Well, what did you do in 1 and 2? What did you do here? You broke down the 96, right? Mm-hmm. So start breaking down 96. Divides by 2, 48. Divides by 2, 24. Divides by 2, 12. Divides by 2, 6. Divides by 2, 3. And I need groups of 2, right?
Yep.
Is that a group of 2?
Yep.
Yep. Is that a group of 2?
Yep.
So I'm bringing out a 2 and another 2. Now they're all coefficients, so what do you got? What do these guys do together?
Do you add them together?
No, coefficients do not add. 5x means 5 plus x. What does that mean? You don't know what 5x means.
Oh, that's a question, and that's just...
What math is happening there? You've got 4 choices. Add, subtract, multiply, or divide. Great. So what's going to happen here? Great. What is it? 2 times 2 is 4. 4 times 5 is?
Sorry.
It's okay. No. 4 times 5 is 20. Now, you've dealt with that. How many A's are there?
3.
3. You need a group how big?
20.
No. What size group are you taking out? Groups of what?
2.
2. Well, I have 3 A's there. Can I take out 2 of them?
Yeah.
So they are going to come out here. There's an A. Did I leave any A's under there?
Yep.
Yeah. So I left under there this 2 times 3, which is 6, and that A. There's also 5 B's under there.
Can you take out 2 of those?
I can take out 2 of them, so B squared. Did I leave a B?
Yep.
Done.
Okay.
Okay?
Yep.
All right. Oh, sorry. Has everybody had their time? Everybody is ready to come back to math class? Well, apparently the computer isn't ready to have you back at math class. There we go. All right. Now, you will notice that I have, first of all, that's one of my favorite fonts, but that's beside the point. I have done something here that I almost never do. I almost always use the proper math word for everything, because that's the way it should be, right? I don't say, well, you have this exponent on the outside. It's like a knight trying to break into the castle, so it has to jump over the wall, right? I don't tell stupid little math stories like that, do I? I show you how to do math. In this case, I'm making an exception because this word fractional isn't really a word. It's one of those words that's been made up in order to make sense. Like the word flammable. It's not a real word. It was made up. So fractional means the exponent. Yes?
Aren't all words made up?
Oh, I see what you're saying. I understand. Yes, but the word flammable was invented because the word for things that will catch on fire is actually inflammable. But in English, in usually means the opposite. So people were like, oh, it's inflammable. I guess I can light it on fire. So they made the word flammable for idiots. Okay? Okay. So, back to where I was before. Fractional means the exponents are fractional. The proper math term there is rational exponents. And rational numbers, we know we define them as being x over y, where y cannot equal 0. So that's why I say fractional. It's just to remind you. But as you do some textbook work, or you maybe take the graduation requirement math exam that is coming for you, maybe you will see the word rational exponents. And that's all it means. Everybody cool? Okay. Now, it's going to be everybody's favorite part of the day because I'm going to insist that you use your calculator. I'm not going to suggest it. I am insisting. Everybody is going to do these 3 things on their calculator, and this is how they are going to do it. The 9 is the base, so you're going to push 9. Then you're going to push your exponent button, whatever it is. Then you're going to push bracket 1 divided by 2, close brackets, equals. Everybody. And tell me what your calculator says. Nine exponent bracket 1 divided by 2 close brackets. 3. Try it again. Push 9. Push your exponent button. There you go. The exponent button that looks either like X with a little Y over it, Y with a little X over it, or a caret. The little mountain symbol. We talked about that yesterday. Oh, we didn't. My other class did. The answer is 3. Now, everybody do that with 27, except it's not 1 divided by 2. What is it now? 1 divided by 3. And what do you get? 3. Now, everybody do it here. 625, exponent button, 1 divided by 4. And what do you get? 5. Now, we're going to stop for a second and we are going to use our brains. You don't need to write down what I'm about to write down. You are simply going to think about it. Everybody should remember this piece of logic. A equals B. Everybody cool with that? That is saying that whatever A is, it's exactly the same as B. Yes? Okay. Now, C also equals b. Whatever c is, it's also the exact same as b. So what does that tell you about a and c? That they are equal. Can everybody follow that first minuscule step of logic? Everybody's cool with that? Okay, now stop for a second and apply this to what we just did. Do we have a relationship anywhere in this unit between 9, an exponent, and 3? What is it, Corey?
9 is 3 squared.
3 squared equals 9. Everybody cool? Don't write it down. You don't need to. You already know that. If 3 squared equals 9, then what is the square root of 9? 3. Everybody cool? Now, what did your calculator just prove to you? That 9 with an exponent of 1/2 equals 3. Yes? So what do you now know about the square root of 9 and 9 to the 1/2? That they are equal. Is everybody with me? Now, look at the expression that I have just highlighted. There are 2 numbers in that expression that are not written down. What are they? Where should those 1 and 2's go? There should be a 2 for the index, and 9 has what power automatically that we don't write down? 1. Now, use your logic. What do you see over here, and what do you see over here? You see the 1 and the 2. Now, think about it for a moment. If that happened here, what is going to happen with that? Corey? It'll be a cube root of what? 27 to what power? 1. Everybody with me? What is going to happen with the blue one? 625 to the 1/4. It'll be the 4th root of 625 to what power? 1. Does everybody see what is happening here? Now, has this happened thrice in math? If something happens thrice in math, how often will it happen? Forever. Now, this is easy to see with numbers, correct? I want every one of you now to write down the rule using letters. Here is what I mean. X to the m over n. Put that into root form. What will it look like? Go. Talk to your neighbor if you need to. Since it's in root form, you know you need a root. There's that. I'll give you that. The rest is up to you. What goes where? Who would like to tell me what they wrote here? Take it away. N root x to the m. Always. Easy peasy lemon squeezy. The denominator becomes the index, the numerator becomes the power, and the x, and this is a word you've only seen once, the base becomes the radicand. That's the proper name for the guy that lives under the root sign. I know it's in your notes somewhere. I haven't used it very often because it's not really important until now. This part of the unit, I'm going to be saying that word a lot. Everybody cool? Now, the photocopying screwed up somehow, and you guys have a B right below here, right? So I've just erased mine and moved it down here so we can do a little bit easier work, okay? So let's look at this situation and see if we can figure it out. What is the base in A? 0.04. So that becomes the radicand. What size root am I looking for? The square root. And all of that is to what power? The third. You guys know how to do BEDMAS. Where should we start? BEDMAS. BEDMAS. Brackets. Is there an operation inside brackets? Square root of that. What is the square root of 0.04? You don't need your calculator. You just need to think about it for a sec. Mr. Myers, I don't know square roots of decimals, but you do. What is it? Not 0.2. No. No. 0.2. Right? Because 0.2 times 0.2 will give me the 4, and then I need 2 decimal places. 1, 2. What goes in the spot? The 0. Now, maybe you didn't follow what I just said, but check this out. Isn't 0.04 the same as 4 over 100? Isn't that 400ths? So if I'm going to square root that, isn't that the square root of 4, which is what? Over the square root of 100, which is 10. 2/10 is 0.2, isn't it? Everybody agree? So this in here is 0.2 cubed. What does 0.2 cubed mean? What does the 3 mean is going to happen to that 0.2? We're going to multiply 2 times 2 times 2, which is what? 2 times 2 times 2. 0.8, right? Well, it's 8. How many decimal places do I need? What happens when I do 0.2 times 0.2? I get 0.04. Now I'm going to add another 0.2. So what do I need? Another 0. So what's this? 0.008. Is everybody with me? Now let me show you again using the fractions, because the fractions are actually easier, even though you guys refuse to believe me. 2/10 was our answer, yes? 0.2, agreed? We're going to cube that. What do you know about exponents? Where does that 3 go? Everywhere. 2 cubed is 8. 10 cubed is 1,000. 8 over 1,000, 0.008. Everybody cool? I picked that one on purpose because it shows everything in the one question about what we're doing right now. The next couple are easier. What is this one? What's the base? 27. So what's the radicand? 27. What root do I need? 3. Third root of 27. And all that is to what power? 4. What is the cubed root of 27? 3. Some of you are starting to memorize that. If not, you got to break it down, right? So that is 3 to the 4th power. That is also pretty easy to memorize. What's 3 times 3? 9. What's 3 times 3? That's 4 3s, right? What's 9 times 9? 81. So 3 to the 4th is what? 81. Everybody see how it works? It's not complicated, right? What's different about C? There's an exponent and another exponent. And we just did a whole bunch of work on this. What do you do with exponents that go over brackets? When it wasn't a fraction, what did you do? If I had x to the 3rd to the 4th, what did you do? Multiplied. So what are you going to do here? Multiply. What is 2 times 1/3? You don't need to think hard about this, guys. It's not a trick. This cup represents 1/3 of something. This cup represents 1/3 of something. 1/3 times 2 is how many thirds? 2/3. Everybody with me? Okay. So this is really 8 to the 2/3, isn't it? Do I know what to do with that? What do I do with that? Where does the denominator go? Index. Where does the base go? Radicand. And all of that is to what power? 2. What is the cube root of 8? 2. 2 squared is what? 4. There's your final answer. Is everybody good? Easy peasy, right? D. D can be done in 2 ways. You could do it with the decimals if you're good with decimals, or you can change it to fractions, right? What is 0.49? Well, we know it's 49 over something. What? 49 over 100. So I like to change it to decimals if it works nice, or to fractions if it works. Then all that is to the 1/2. Where does the 2 go? Index. Where does the 49 over 100 go? Radicand. And all that is to what power? 1. So do we even care? Nope. Good. I didn't trick you. What's the square root of 49? 7. What's the square root of 100? 10. 7 over 10 is what as a decimal? 0.7. And that makes sense, doesn't it? Because if I do 0.7 times 0.7, I'm going to get 49. And I need 2 decimal places. 1, 2. Cool? Everybody? What's different about E? It's a decimal. But what is it really? It's 1.5. Make 1.5 a fraction. Three over 2. So isn't this 16 to the 3 over 2? Isn't it? Isn't 3 over 2 1.5? And when I have it as a fraction, can I deal with it? Sure I can. Where does the 2 go? Index. What goes to the radicand? 16. And all that is to what power? 3. What is the square root of 16? 4 to the 3rd power. What is 4 to the 3rd power? 64. Now, you guys have to do F. Well, I have a sip of fine coffee. Can't do it with the decimal. What do you got to do? What is it really? 81 to the 3/4. Where does the 4 go? Index. Where does the 81 go? And it's all to what power? Now we already know what the 4th root of 81 is, isn't it? Because we did it in B. What is the 4th root of 81? 3. So this is 3 cubed. What's 3 cubed? 27. Done. Everybody good? What have you noticed about all 6 of these examples? Look at all the answers. Did they all work out? They're all perfect, aren't they? Is that really going to happen? No, it isn't. In the real world, there's other numbers than perfect squares and cubes, right? So sometimes we are forced to use our calculator, like here. We know what that is. What is it? Don't go to your calculator yet. Just tell me what this really is. Write it in radical form, because right now it's an exponent. What would that be? What goes where? 5th root of 8, all squared. Does 8 have a fifth root? No, what's the biggest root we can get out of 8? We can get a cubed root, right? 3. So there's nothing bigger. So when you get to a question that you cannot solve using this method, then you have to use your calculator. And you don't need to do this. You can go straight from here with the 8 y to the x bracket 2 divided by 5. Everybody punch it in. Make sure you get the same thing. What are you getting?
2.297399671.
Is that rational? No. So we'd round it off. Do I care where you round it off? I'm so tired of caring. You want to make it 2.3, make it 2.3. Okay? You couldn't make it 2.2. You would have to make it 2.3, wouldn't you? Because the 7 bumps up the 9 and the 9 bumps up the 3. Everybody cool? Do the next one. You know that it's the 7th root of 0.6. You know that doesn't exist. So you know this is a calculator situation. 0.6 exponent bracket 15 divided by 7. And what do you get? 3346, blah, 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 blah. So what would you round it off to? It starts out at 0.334. 3346, I think he said, right? Okay. So 0.3, no problem. 0.33, no problem. 0.335, no problem. Don't care. They're all the same. Everybody with me? All right. Now, we're going to do these 3 questions together, and then we're going to write our quiz. So, here is a formula with B's and M's in it. Are those values explained in the question? Yes. B is the brain mass, and M is the mass of the animal. So you've been given a formula. B equals M, I lie, 0.01 M to the 2/3. Do you have either a B or an M in the first one? You have an M. So where does that go? 0.0127 to the 2/3. Now, bed mass. What do we do first? There's no brackets. That bracket is just holding the spot, just the exponent. Now, this is telling me I need what? What is this telling me? We just did a whole lesson on it. What is that? That is the cube root of 27 squared. Does the cube root of 27 exist? Yes. What is it? 3. Do I know what 3 squared is? What is it? So I have 0.01 times 9. Right? Don't need a calculator for that. What's 9 times 1? And I need how many decimal places? 2. 9 with 2 decimal places. 1, 2. What goes in the hole? 0. Everybody got it? Don't need a calculator for that one because this is doable. Are you going to need a calculator for B? For B, it's going to be 200 to the 2/3, which means the cube root of 200 squared. Does 200 have a cube root? Let's think about it for a sec. 5 cubed is 125, right? 6 cubed is 216. So no. So this one, we'd need a calculator. What about 60? Does 60 have a cube root? No, because 3 cubed is 27. 4 cubed is 64. So I would need a calculator there. Is everybody with me? Make it so. Try it right now with your calculators to get me an answer to both of these. I'm going to write the workout. Word.
Great wife, actually.
Okay.
I got her
Sweet.
because, you know. And
All
then-
right.
Yeah.
And I got to bring it in, or can it go online?
No, online, in store, anything.
Sweet.
No
Thanks.
problem. And it's only for the 5th till the 8th.
No, I better get her in there then.
Yeah. I'm working on Saturday, so tell her that.
Okay.
Yeah.
What are those?
Coupons
Four.
for the store she works at.
Oh, which is?
Never mind. I don't care. It's for La Vie en Rose. My wife needs a new swimsuit anyway. Ah! Excluding swimwear. Oh well. Okay. How are you going to do this? How did we do this with our calculator? 200 exponent what? 2 divided by 3. Now the other thing is what Liam said. I was right the first time. What Seamus said. He said just do the cube root of 200 to the second power, which is cool if you know how to get cube roots on your calculator. A lot of calculators have a cube root button, but not every one. So it's a bit of a pain, right? But every calculator has an exponent button, so you can always use that. Do I care which one you use? No. And then what are you going to do with that answer? Times by 0.01. And you're going to get an answer. Yo. Sure. 0.34. What about this one? It's going to be 60 exponent 2 divided by 3. Or, if you know what you're doing, cube root of 60 squared times 0.01. What do you get? 0.2. Yeah, yeah? Yeah, yeah, yeah. Okay, now stop for a moment. I'm going to explain the next couple of minutes to you. You have 29 minutes left in class. The quiz is 4 multiple choice exponent questions and 14 simplifying radical questions. They're not multiple choice. Yeah, but they're all small ones, like square root of 32, right? They're 1 or 2 step ones. I'm going to give you the rest of the period, but I want to mark it today. The morning class, I gave them 18 minutes. They didn't use it all. Everyone was done by like 16 and a half. That's not to pressure you. I'm just saying that it's plenty easy to do in the amount of time you have been allotted. And we finished this part quicker. So you actually have a little bit more time. All right? So here's what you're going to do. You're going to attempt the quiz. You're going to write it. You're going to keep it, of course, because you're going to mark it yourself. But if you finish, you are not talking to your neighbor because I have made you time in which to do your homework, which is page 106, entitled page 277 or 227, because it came out of a textbook and it was page 227. Okay? And as always, when I give you textbook work, I have supplied you with the answers on page 107. And that's all I want you to do tonight. If you get it done in class, you got nothing to do tonight. Okay? Okay. Desk clear except for a calculator. And pencil, duh. Pencil shouldn't be on your desk, it should be in your hand. Huh? Just exponents and radicals. Yep. No multiplying. Nothing that we did yesterday. Just exponents and simplifying radicals. And this font is Spring Fling.
Oh, amazing.
Because it's springtime. Well, almost. No, it is. Spring started on the 22nd. Even though we had snow on the weekend. garbage. Yeah, that's Barbera. Barbera. Snow belongs in the mountain. Snow belongs places we should visit. No. That's multiplying. That's what we did yesterday. Let's mark it. Who would like to give me their answer to number 1? Yo. Pardon me? D as in doorknob? Absolutely correct. Does anybody need to see why it is D? Or is everybody happy? Sure. So, that 3 has to go everywhere, right? So I get a cubed over 8, a to the 6th, because those two a's are going to make a squared, right? Okay. So I got 3 a's up there and 6 a's down there. What's 3 minus 6? Negative 3, right? Right? Okay. So I'm going to have negative 3 a's. Oops, a to the negative 3, which isn't allowed. It's got to go down to the denominator. So it had to be 3 down there. The 8 was already there. Am I allowed to have 0 on the top? No, it has to be 1. Who's going to give me their answer to number 2? You already did one. C, as in Cafe Cucamonga, it is C. Does anybody need to see why it's C? Or is everybody going to be okay? But seriously, folks, does anybody need to see why it's C? Everyone's cool with that one? Nobody needs me to go over it?
I think everyone will be okay.
All right. 3. Who's going to give me their answer for 3? 3's a tricky McTrickleton one.
It's A-okay.
What is it? A. It's A. Okay. Does anybody need to see why? You want to see that one? Yep, no problem. So, on the top, we got 2k to the negative 2. And on the bottom, we got 2. And then this is going to be negative 12, right? 4 times negative 3, right? And then negative 2 plus negative 12 is k to the negative 14, right? The 2's cancel, because you got 2 over 2. And negative 2 minus 14 is the same as negative 2 plus 14, which is k to the positive 12. And since it's positive, it can stay there. Good? All right. Who's given me their answer to 4? As if I didn't know. A, as an awesome job at exponents. See what I did there? Yeah. Does anybody need to see why, or are you good with that one? That one's not too tricky because everything is the same letter. Is everyone okay with it? Alrighty. And finally, number 5. Tricky McTrickleton. Which is it? Dingleberry. Oh, D as in Dingleberry. Yes. Good job. Does anybody need to see why? Excellent. That page is out of 5 because they were all multiple choice. On the back, they are all out of 1 because it doesn't matter how complicated the question is. It's always the same work to do. So, would anybody like to give me their answer to 6? Corey. 4 root 6. Excellently done. Number 7. Corey. 3 root 5. And I heard it from somebody over there too. Nice. 8. 4 root 2. Shamir, way to step up here and take over. Well done. 4 root 2, he said angrily.
2, 1. Yay.
And number 9. Who's up for number 9? Corey. 24 root 10? Root 5. Give yourself a half mark. You need to see why, obviously. 80 is 16 times 5. What's the square root of 16? 4, so it comes out, and we left the 5 under there. Underwear. What? Okay, Ash.
Negative 56 root 3.
Yeah! Somebody stop her. And number 11.
I got one.
Okay, Ash, even though I heard her say it, but you can say it.
Oh, fine. 10 to root 3.
10 root 3. Now, 12, 13, and 14 have letters, but does anything change? No. What do we do with the 343? What comes out to the front? Well, just what's the answer? And then I'll explain if I need to. Negative 49. A squared B root 7. Perfect. Does anybody need to see why?
Can we go back to 9 for a second?
Uh,
I just want to see something.
yeah.
Yeah, just worry about something. But never mind.
Okay.
Yeah.
13. Ash.
Negative 80.
Ooh. Finish it off, though.
V squared U rooted 24.
Yeah, u v squared root what? 24. Okay, that one apparently we need to go over because nobody else, unless somebody else wants to offer an answer. Oh, Raul! Whoo! New guy. Stepping up to the plate. Just waiting for it to erase, Raul. It's anticlimactic, I know. It would be really nice if you could just drop the mic and walk, but we can't because this is a piece of crap. No, Raul is doing it, Louis. Okay, Raul, hit me. Negative 40. U. V squared. Root. 2u. Absolutely right. Good job to you, Raul.
Oh, yeah, it was a 2, but it looks like 24. I get it.
But you wrote it.
Yeah, I know, but my writing's messy.
Okay. And finally, number 14. Yeah. Uh-huh. What? He waited patiently. Negative 20. A squared. Root 2b. Nice! You must have had a very good math teacher. That page is out of 14, making the whole thing out of 19. Now, one of my students that has been my student forever, and he was even a peer tutor, every time I made that joke, he would always say, yeah, Mr. Keeley. It was hurtful to me. But he was joking, just like I'm joking. I'll get those numbers from you tomorrow. You have a little bit of homework, and it's 2:24. You can relax, decompress, take a load off. You guys take the last 3 minutes off. No problem, Tyler. Yes, Ayla? For the review? Which review? The trig one? What do you mean I put a wrong mark? Okay, that's just fat fingers. 6 is right below 9 on the keypad. I'll change it. I'll write it down right now. You need a 19 instead of a 16. My pen, my pen. Somebody stole my pen.
That's right by the remote.
Thank you. So, Ayla needs a 19.
three paths. That's actually